Assalamu alaikum students. I hope you all are doing well. Today we will continue chapter number 5, chemical reactions, and the topic which we will discuss today is types of chemical reactions. There are many types of chemical reactions, but generally there are 5 types of chemical reactions which we will discuss today. The first type of reactions are called as addition reactions. Second type are called as decomposition reactions, single displacement reactions, double displacement reactions, combustion reactions. Now we will discuss each one of these reactions one by one in detail. The first type of reactions are called as addition reactions. These are also called as combination or synthesis. They are defined as the chemical combination of two or more substances to form one compound is called combination reaction. A plus B gives rise to AB. Let's elaborate it with the help of a few examples. Like when hydrogen gas combines with oxygen gas, it forms water. So here the two non-metals are combining together to form a single product. Now next example is again the combination of hydrogen gas but with chlorine, and hydrogen chloride is formed. Next example is the synthesis of ammonia, where hydrogen gas combines with nitrogen to form ammonia. Here in these three examples, on the reactant side, two non-metals are combining together to form a single compound, particularly which is called as a covalent compound. Metals can also combine with non-metals and they will form compounds which are particularly called as ionic compounds. Like magnesium reacts with oxygen to form magnesium oxide. Similarly, when sodium metal reacts with chlorine gas, it forms sodium chloride. In all of these 5 examples, the reactant site consists of only elements, whereas there is a single product, that is a compound, is formed as a result of the addition reactions. Sometimes the reactants may consist of either one compound or simply the reactants consist of two or more than two compounds. Like when calcium oxide combines with carbon dioxide, it forms calcium carbonate. So here calcium oxide is a chemical compound, carbon dioxide is a compound. So both of these compounds combine together to form a single product which is called as calcium carbonate. Next example of the type of reactions is the decomposition reactions. Now decomposition reactions are defined as a chemical reaction during which a compound splits up into two or more simple substances. It's called a decomposition reaction. AB gives rise to A plus B. Now this breakage, this decomposition is considered as it is the opposite of combination reactions. And such reaction take place only when some energy in the form of heat, light or electricity is applied to the reactant. But usually heat is required to bring about decomposition of compounds. Let's elaborate it with the help of a few examples. First example is decomposition of potassium chlorate to form potassium chloride and oxygen gas. Since heat is required to bring about this change, so a capital Greek letter which is called as delta sign is put on the arrow to represent that heat is required for this decomposition reaction. Similarly, decomposition of calcium carbonate also requires heat to decompose into calcium oxide and carbon dioxide. Lead nitrate decomposes on heating to its constituent lead oxide, nitrogen dioxide and oxygen gas. Now in all these three examples, heat is required for the decomposition. So such type of reactions are particularly called as thermal decomposition reactions. Sometimes electricity is also used to carry out the decomposition reaction. Like the decomposition of water needs electric spark to decompose into hydrogen gas and oxygen gas. Similarly, sodium chloride decomposes when electricity is passed through molten sodium chloride and it converts into sodium metal and chlorine gas. Another type of reaction is decomposition of silver chloride, but here light energy is required for the decomposition of silver chloride into silver and chlorine. Now those reactions which require the heat are called as thermal decomposition reactions. Now those reactions which require electricity for the decomposition, these are particularly called as electrolytic decomposition reactions. And those which require light energy for decomposition, these are particularly called as photolytic decomposition reactions. Third type of reaction is single displacement reactions, or sometimes they are also called as single replacement reactions. The chemical reaction in which one element replaces another element in a compound are called as single displacement reactions. Like general reaction A plus BC gives rise to AC plus B. Now A is more reactive, more powerful, so it has the ability to displace B, which is already present in a compound, and B will be displaced while A will combine with C. Now it's important to remember here that only a more reactive element can replace a less reactive element in its compound. Let's understand it with the help of example. The first example is between the reaction of iron and copper 2 sulfate to form iron 2 sulfate and copper. Here, since iron is more reactive than copper, so we can say that iron will displace copper from copper sulfate and will form iron sulfate and copper. Now if we will reverse the reaction, like copper react with iron 2 sulfate, since copper is less reactive than iron, so no reaction will take place. Another example is between zinc metal and iron 2 chloride, and it will form zinc chloride and iron. Since zinc is more reactive than iron, so what will happen? That zinc will displace iron from its position and will form a new compound which is called as zinc chloride. Now, how can we determine that some metals are more reactive and some metals are less reactive? By a series which is called as reactivity series of metals. And here the metals are arranged from least reactive to most reactive metals. Like potassium, sodium, calcium are the most reactive metals, whereas silver and gold are the least reactive metals. Now you can relate well that here in this example iron and copper, since iron lies above copper in the reactivity series, it means that iron is more reactive than copper. As a result, iron can displace copper from its compounds. In the other example between zinc and iron, now zinc lies above iron in the reactivity series. It means that zinc can displace iron from its compounds, whereas iron cannot displace zinc from its compound since iron is less reactive than zinc. So, in a nutshell, we can say that whenever a metal which is present above in the reactivity series of metals, it can displace the other metals which are present below it in the series. So a more reactive metal can displace the less reactive metal from its compound. Fourth type of reactions are called as double displacement reactions. These are defined as the reactions in which two compounds react by an exchange of ions to form two new compounds are called double displacement reactions. Now here for the first time, on the reactant side as well as on the product side, there are two compounds like here AB and CD. Now such type of displacement reactions usually occur in ionic compounds, and we know that in ionic compounds the formula of positive ion is always written first. So here we can say that A is positive ion, B is negative ion, C is positive ion, D is negative ion. So how can we form that A positive ion will combine with the negative ion of D? Hence it will form AD. On the other hand, it will not form BC because since it's an ionic compound, so positive ion is written first. Hence the formula will be Cb. Like you may say that sodium chloride, sodium is always written first. Magnesium oxide, sodium bromide, potassium iodide, calcium sulfide, calcium oxide. In ionic compounds, the metals, the positive ions, are always named first. So here it's important to write the general reaction that AB plus CD won't give rise to BC or something else. Rather, it will give rise to CB and AD. Examples. First example is of the neutralization reaction. NaOH plus HCl gives rise to NaCl plus H2O. Here, sodium ion is the positive ion, and here in HCl, hydrogen ion is the positive ion. OH negative ion, hydroxide ion is the negative ion here, and Cl negative ion is the negative ion here. So how they will form the new compounds? That sodium ion will combine with chloride ion and will form sodium chloride. And on the other hand, H plus combines with OH and we can write HOH, or most commonly we write it as H2O. Another example of double displacement reaction is of precipitation reactions. Now, precipitation reactions are those reactions in which some precipitate is formed. Example is of silver nitrate when it reacts with sodium chloride. Now again, silver is positive ion, sodium is positive ion, nitrate ion and chloride ions are the negative ions. So the two compounds which are formed, it will be silver chloride and sodium nitrate. Such type of reaction in which there is some solid substance formed as a result of the reaction between two aqueous solutions, such reactions are called as precipitation reactions because precipitates of silver chloride have been formed. The last type of reaction is the combustion reaction. Combustion is a chemical reaction that occurs between a fuel and oxygen that produces energy, usually in the form of heat and light. It is also known as burning. General reaction is simple. Fuel plus oxygen gas will give rise to carbon dioxide gas, water vapors and energy. Sometimes if there is insufficient supply of oxygen, instead of carbon dioxide, another oxide is formed which is called as carbon monoxide. Examples. First one is reaction of methane, combustion of methane. Methane reacts with oxygen to form carbon dioxide and water vapors along with the release of large amount of energy. And we have studied that this energy is utilized on domestic purposes as well as for running vehicles. Another example is of C8H18. When reacts with oxygen, it again forms carbon dioxide gas, water vapors and heat energy is released. Here C8H18 is gasoline, or in common words we say it as petrol. So during combustion reactions, one of the reactant is always oxygen and the other reactant may be any type of fuel, and the products are almost same in most of the combustion reactions, which are carbon dioxide gas, water vapors and heat energy. I hope you have understood the lecture about the types of chemical reactions. Thank you. Allah Hafiz.